Hello friends, welcome to EPG Pathshala. My name is Jenny Mendes and I am from Sophia College, Mumbai University. Today we are going to understand memory. Memory is one of the most fascinating topics, not only for psychologists, but for neurologists, for educationists, for everyone. Because memory comes from a Latin word, memere, which means mindful, which means to remember. Memere was the name of a Greek goddess. Memory is that behavior which is modified due to learning. Memory is learning that has stayed with us. Learning is a change in behavior due to practice or experience. Of course, it can be overt or covert. I have learnt English by studying it, and now I can speak it from memory. Most of our behavior is learned. Everything that is me, myself, what is unique to me is learned. We take our memories for granted. Our memory allows us to remember events, big or small, of our lives and that of the world. It allows us to remember friends and their worlds. It allows us to cook, to knit, to dance, to wash clothes, to teach, to drive a car, to speak a language and pass an exams. Our lives are our memories. Snatch that from us and there's nothing left. We are our memories. Memory is that process that allows us to store information and then later remove the information when we need it. Now, let's understand how this process works. There is encoding, that is, information has to get into our system. So encoding is taking place both automatically and with effort. Example, you are now listening to me and you are trying to understand what I am saying. You are making this effort, but at the same time, you hear sounds from your environment. You see the color of my clothes. There are lots of things lying near you wherever you are. All these stimuli will enter your system automatically. You have to make no effort on your part, and a large amount of information enters our brain with effort and attention. When you first tell me your name, I will repeat it, connect it to other information in my brain, like think about its meaning, connect it to something else. By spending this time with your name, I am encoding it in my memory. So encoding is where I take in the information. Now, once I have taken that information, I am going to store it. So storage is to place that information inside. Like for instance, I know where my college is, and in my kitchen, I know where sugar is kept. So surely there is some way, some pattern I have used to remember this information. And the third one is retrieval, which is to get back the information whenever I need it. We have to be very thankful for our memory. We take it for granted except when it creates malfunctions. That is, when we start forgetting. Memory defines my life. Our memory is vast. You won't even imagine that, because we have huge amounts of voices, faces, tastes, sounds, smells, places, events. I'll do a small experiment with you. If I have to show you 2500 slides of faces and places and immediately later show you 300 of these with 300 new slides. Now these 300 new slides which you are seeing, they were never exposed to you. Out of the 600 slides, can you imagine that you will recall 90% of them correctly? That is the vastness of our memory. A good memory is helpful. So is forgetting. Now you are surprised. Why is forgetting helpful? Imagine if you could remember everything and not forget anything. How would life be? Terrible. Luria in 1968 reported a case of Mr. S, who could remember series of 70 digits backwards, and he could remember this years later. My goodness, what a feat! I'm sure you feel envious. I'm sure you think, I wish I could do it. No, but he could not discard any information. Mr. S, if he read a story, he could not reproduce that story for you because he would repeat that story exactly the same way that he read. He could not summarize it. Lots and lots of information dominated him. A more recent case of Miss A.J. reported in 2006. She was exactly like Mr. S. Her life was a running movie that never stopped. Her memories were uncontrollable and she found it exhausting. She could not sleep because everything that she did in the day came in. To understand memory, let us go to a classic theory of Atkinson and Shiffrin. Of course, this theory has been modified. Many improvements have come in, but his theory has stayed because it's classic. Now let's look at memory in terms of duration of time and information from the outside world. Now, when we have data entering our system, it first goes to the sensory stage. Then it goes to short-term store. And finally it goes into the long-term store. Now suppose I give you a flash of a printed page to you which has 9 digits, 3 in a line. So it's 3, 3 and 3. I flash it to you and immediately remove it. Now everyone is able to recall 3, 4 or 5 digits. Now this is visual memory. It's also called iconic image. It's fleeting. It's like a photograph. The eye registers it, then the image fades because other images come into the way. Now in this way, we have echoic or auditory images, that is images for sounds. Now a lot of information enters the sensory memory every second, but lots and lots of it come out also. We are at the same time encoding and paying attention to some of it. Most of it, of course, as I told you, fades away. With selective attention, some of it will enter the second stage, that's the short-term memory. I'm sure you have forgotten the name of the person you have been introduced to immediately, because if you do not do something with that name, it will go away. You have to work with that name. Your friend asks you to dial a telephone number, so you listen to it. She says it aloud, and then you go with that number to the phone. Now you're holding that information in your auditory sensory register. You dial the number correctly. You get your line. And then if you are asked about the number, you don't know it because it has just evaporated. This was short-term memory, which is very brief as 18 seconds. While its attentional control is working memory. You know, working memory is like a sketch pad which one uses. Suppose I say, what is 10 plus 4? So now you need to keep this 10 plus 4 onto a rough pad so that you can add that and say 14 and give the correct answer. Short-term memory is limited both in the capacity of information and the time. This place holds data in the form of codes. So there are visual codes, image codes, phonological codes, that's acoustic codes, and motor or physical action codes. People can hold 5 to 9 meaningful bits of data. George Miller, a famous psychologist, called it the memory span. You can remember the man who couldn't forget could remember 70 units and more. We can hold only 5 to 9 units. And how long? We can hold it for only 20 seconds. This is the time or duration of the short-term memory or of the workstation or the workspace. Now this workspace is working with that information and is going to push that information into long-term memory. Now long-term memory, look at the word long-term memory, it's a library. And here information of short-term comes in and stays there. Actually, ideally, it stays there for life. Depends on how you've kept it in. So therefore, you have to make notes, you have to rehearse. For example, an actor. Suppose he repeats and repeats and repeats his lines and remembers every word of it. This is known as rote learning, and this is what you do sometimes in your exams. This rehearsal is not very effective. It will be there, no doubt. But suppose you go deep into the meaning of the material, like the actor goes into the scene, imagines himself and integrates that scene with his own life, he is going to remember these lines for life. Now let's look at the different types of memory. One is episodic memory. This is memory which is linked to me, to my personal experience. These are the episodes of my life, and anything that's personal is episodic. Your childhood friend, your favorite film, what you ate yesterday, the walk you went today morning. This is personal information and it's known as episodic memory. The other type of memory is semantic memory. We learn so many things about the world, capitals, currencies, general knowledge, names of presidents. These are not personally linked to us. Any information that's not personally linked is known as semantic. And the other thing is procedural memories. This memory is implicit. Typing, skipping, this memory is implicit. Once you go into the water, after years, you just swim. Tying your shoelaces, typing. When your fingers are on the keyboard, they just fly. You don't have to think about the keyboard. Combing your hair, flipping a chapati, skipping, stitching, all these are implicit muscle movements which become so automatic. This is procedural memory. Now, are you worried about your memory? I'm sure you are. Eric Kendall, Mriganka Sur, V.S. Ramachandran are scientists who have worked on the brain and its memory. What do we know about memory? First, let us look at the brain. To understand memory, we have to understand the brain. Now meet Mr. H.M. Have you heard of him? He's a very, very important patient in the history of brain science. He had an injury and suffered from frequent seizures. To treat his epilepsy, a very famous neurosurgeon of that time, Dr. Scoville, removed parts of his brain, that's the hippocampus, which is a very important part of the brain. Mr. H.M. was 27 years old at that time of surgery. He was relieved of his convulsion but started showing a strange type of forgetting. This forgetting is now called anterograde amnesia. He could remember everything prior to his surgery. So all his memory before the age of 27 was intact. But he was incapable of new learning and could not convert short-term memory to long-term. Now you will wonder, what is this? He met his doctor every day in the morning, but would not know her, would not recognize her. She would introduce herself, say her name, but H.M. could not transfer this information from short-term memory to long-term memory. She was a new person to him every day. Prior to H.M., we always believed that the whole brain was involved with memory. Now we know the different parts of the brain, and for sure we know that the hippocampus is responsible for this transfer from short term to long term. And his surgery was the removal of the hippocampus. Now, Mr. H.M. would look at the TV remote as if it was an instrument from the moon. He never knew how to use it. He never remembered what he had for breakfast. Every moment was a new moment. Every memory was a new memory. Actually, there was no memory. Every meeting, every talking to him, he did not remember that he had ever met you. He read books, but he did not remember any of the material he has read. He could play chess, but if you played it very slowly, he forgot the moves. His uncle had died, and he showed shock when you told him about it. He was sad only for that moment, but then he immediately forgot it. His memory of his face was a young, dashing man. And whenever he saw himself in the mirror, he was shocked at himself because he couldn't imagine that old face was his face. But he could do automatic processing, like mirror drawing a star. He could draw that, and one saw improvement in that drawing. So procedural memories were intact. He was a very cheerful man. He never got tired, though everything was new for him. Science studied him for 50 years. He died in 2008. His brain has been preserved in 2000 slides. He spent his life forgetting, and we shall remember him for generations to come. Eric Kendall was a psychiatrist. He worked on memory for 40 years and won the Nobel Prize in 2000. In order to study human memory, he was searching for a less complex system. But at the same time, that system had to have a variety of behaviors. So he was looking out for an animal model system. Now, before coming to his story, I will take you to a familiar animal, a pest in India. It is the great African snail. Now, when you keep cabbage juice, it smells very good. The snail likes it and it is attracted to it. It moves towards it to eat it. Now you mix this nice smelling cabbage with a bitter tasting substance called quinine. Quinine has no smell. Our snail now will move towards the good smell, tastes it, and is repelled by the bitter taste. Henceforth, it will never go to this food. Our snail has changed. It's no more the same. It has changed its memory. The bitter taste of that quinine is in its memory, and that's why it will never go again. Eric Kendall tells us that during learning, the shape of our brain changes because the connection of the billion neurons which the brain is made up of gets stronger. How did he show us this? I just told you he was looking around for a model system whose processes are similar to the human brain. He found the sea slug, Aplysia californica. We have 100 billion neurons. You know what is 100 billion? That's 100,000 brain cells. Whereas this snail has only 20,000 neurons. Our neurons are tiny in diameter, that's 10 microns, which is 100 times smaller than a millimeter. We need a powerful microscope to see our neurons. The neurons in this snail, which has only 20,000, can be seen with the naked eye. So Eric Kendall worked with this model, which showed how learning happens and how memory is formed. Learning can be studied by altering the behavior, and retaining that altered behavior is memory. This study showed a simple fact, how the shape of the brain changes when we learn something new. The brain has a lot of plasticity. It changes every moment with learning. I'm sure your brain is also changing right now. When water is mildly sprayed at a part close to the gill called the siphon, the gill shows small withdrawal like this. The gill is an external organ that extracts oxygen from water. Repeated sprays will show gill withdrawal. Now you give a shock to the tail and there is a big withdrawal. After recovery, now if you give the same mild jet of water to the siphon, there is a big withdrawal. Why? Because it anticipates the shock. The animal has learnt, the animal is sensitized, and this is shown for the mild spray. Now suppose there is a loud noise where you are sitting. You're very frightened. After this, I give you a small sound which will scare you because you have become very sensitive. That sound went into your memory and it is stored there and you are being very adaptive. How did this happen? Since the neurons are large, Eric Kendall could trace the neurons and their connections to three structures: the tail shock neuron, the water jet sensing neuron from the siphon, and the gill withdrawal motor neuron. These three structures he could see very clearly. In the naive animal, before learning, a mild shock will give rise to a small contraction. I just told you about it. This mild contraction will have a lot of calcium mobilized in the neurons. There is something called the pKa, which will stay inhibited. Nothing will happen to it. And very little neurotransmitters will come out. Calcium gets mobilized and neurotransmitters are released. The pKa is inhibited. Now with the tail shock, the contraction is very large like that. pKa is now made active and there is a large amount of neurotransmitters. This is short-term learning. Now in long-term learning, if you go on giving the shock, the pKa will make protein for a new growth, a new sprout, an additional branch on that neuron, thereby changing the neuron structure. New memories are formed by changing the shape of the brain. This is a dramatic finding for which Eric Kendall won the Nobel Prize. Our brain's architecture proves that the brain is highly plastic. This fine architectural change in the brain is called neural plasticity and is the cardinal principle of behavioral learning and long-term memory. Thank you.